Hi, everyone, and welcome to Working as a Data Analyst versus Data Scientist. Today, I want to talk about my experience having worked as both a data analyst and data scientist, highlight what's important in both roles, and talk about some of the differences. This is 100% based on my experience, so this doesn't mean that what I'm going to say will apply to everyone and every job. And I definitely love to know your experience as well, if you've worked either as one of these job titles or perhaps have also worked as both. Please do leave feedback. And I'm going to break this into four sections. First, we'll talk about coding, then software and tools, methodologies, and then what a final product actually looks like for both. And then the layout will look like this. I'll first talk about what applies to both, then what applies as a data analyst and a data scientist. And I started making a Venn diagram, but I think this format works a little bit easier. So let's get into coding. In both positions, I used a ton of SQL. I think maybe 70% of the job is really understanding the data you have and how it fits together. Exploring, joining, cleaning, wrangling the data is a huge part of being a data analyst and a data scientist, and probably one of the top languages to really understand. Not understanding how nulls may affect joins, ordering data, or not understanding how different formats of data interact can give you really odd results. So this is really key to being able to access your data, join your data, and to understand your data. As a data analyst, we did a lot of statistics and some basic modeling. So we used a lot of SAS and R. And then as a data scientist, I mainly coded everything in Python. I used a little Spark and then a tiny, tiny amount of R, but not enough to put that in the both category. Next, let's talk about software and tools. For both, Microsoft Office is still used across the board. PowerPoints are still a classic way to present topics. Minor analyses and graphs are amazing in Excel, and a lot of documentation happen in Word. Excel is also really nice because most people understand the basic functionality of it. So if you're sending a functional workbook or you have some data where you make a graph, generally everybody from every team kind of understands what they're looking at and how to use it. As a data analyst, we used Microsoft SQL Server. We did dashboarding in Tableau, and then of course used RStudio for R and SAS for coding in SAS. And as a data scientist, a lot of our data access happened in Databricks, Amazon AWS, and Snowflake. Our dashboarding happened in Domo, and we used JetBrains software such as DataSpell and PyCharm for Python, and then DataGrip to access data. We also wrote a lot of notebooks and created dashboards in Databricks. This is really nice because it offers multiple languages, which you can easily switch between in a notebook, and you can track model performance in ML Flow and create dashboards. So this is really Databricks was really nice to create a notebook and be able to switch between languages. And I know this is maybe a little bit shocking, but as a data analyst, we did not use Git or GitHub. All versioning was done old school, where you kind of just create a copy of the code. But as a data scientist, especially when you are integrated with other teams and you create models that rely on other teams and feed into the work of other teams, Git and versioning and having good versioning is really a must. Okay, so next let's talk about methodology, so the really fun stuff. For both, the roles heavily required data cleaning and standardizing. Both roles had basic modeling, such as survival analysis, linear regression, logistic regression, and ANOVA regression, and both jobs had plenty of significance testing going on. What I really enjoy the most is investigative analytics, where someone says, hey, find me something interesting, or look into this a little bit more, and then you get free reign to really dive into something you may have seen in the data or trends that you're tracking. So a lot of that happened in both roles. Descriptive analytics, basic statistics, and then a lot of trend analysis happened in both. As a data analyst, we did a lot of program evaluation, which is really looking at, did a certain treatment work or is a certain intervention beneficial? And then as a data scientist, this was really a fun role. I was able to work on and develop more models. One of my favorite things I worked on, which wasn't really a complicated model, but it was still a lot of fun, was creating an index for social determinants of health. I got to work on an isolation forest, a REMA model, which were part of the anomaly detection. We did trend decomposition, matched cohorts. We created a binary classification XGBoost model, and a lot of feature engineering. Both positions definitely had perks and require a ton of puzzle solving and investigative work. Although the data analyst position didn't have as many modeling opportunities, we did get to work on really meaningful projects. But I think what you will see oftentimes is that a data analyst position, they're usually at companies that don't really have the room for machine learning or advanced techniques. Or maybe they also don't have the client base or audience that's really receptive to it yet. So that was really the main difference between the type of projects we got and the type of methodologies we got to use. And next, let's talk about what a product actually looked like for both of these positions. And what I mean when I say products is, what does the final thing look like that you hand over? So if someone says, I want to know which patients are at risk for developing cancer, do you hand over a list of patients, or do you hand over a number of patients? Do you create a dashboard or hand over the code that includes the model to help predict these members? Um, so what does the final thing look like that you hand over? In both, a lot of final products were Excel spreadsheets, dashboards, written reports, code that you would hand over to the next team or another team member. Other visualizations that were created and maybe put in a Word document, and then base statistics. As a data analyst specifically, we did our dashboarding in Tableau. We created a lot of patient lists that were kind of just target opportunities. We created a lot of data subsets as our final product, and then we did a lot of state reporting. As a data scientist, we were able to really integrate our model output into a platform that was client facing. So this means working with engineering and front end developers to ensure your model results are properly represented. And we did a lot of Domo and Databricks dashboarding. I want to say the main difference here is that as a data analyst, the project kind of always started with us and ended with us. And what I mean is that we were directly accessing the data, we did our analytics, and then kind of handed those numbers or that final product to whoever had that ask. But as a data scientist, we were more of an integrated team, and so we worked with other teams, and the project usually started with data managers, then went to us, then went to engineering, and then went to front end developers, and then went to clients. So we had a lot of handoffs both before and after we were able to touch the project. And let's look at everything together. So this is everything we just talked about together. The intersection between data analyst and data scientist really captures what you can expect in both roles. The data analyst position, from my experience, didn't offer as much creative freedom and had a little bit more structure to it. The data scientist position offered a lot of creative freedom and much more required communication across teams. And both positions allowed for group work, independent work, cross-functional teamwork, and both positions also allowed for presentations to shareholders and to clients.
Well, thank you so much for watching, and please leave feedback.